Okay, now we're going to build our perfect competition diagram or pure competition diagram. We're going to start by looking at this information we talked about last time. And we're going to use some key parts of it in order to build it, in order to get a good idea of the general shape. So normally we have price on our y-axis, quantity on our x-axis. But rather than this being the entire market, this is going to be from the perspective of one fir. Let's begin with marginal revenue. That's something we're going to have to pay attention to. Marginal revenue is flat. This is our pure competition, so everyone is a price taker. And what that means in practice is that no one can influence the price. No matter how much quantity you produce, the price is always the same because everyone is a price taker. Price is the same thing as marginal revenue. Price is also the same thing as demand. In other words, our demand curve is perfectly elastic. And why shouldn't it be? There's tons of buyers and sellers selling exactly the same thing. So from the perspective of one firm, there are tons of perfect substitutes. Of course, it's going to be perfectly elastic. Increase your price by just a little bit and no one will buy it. You'll also notice that we have marginal cost. So sometimes you'll see a marginal cost kind of looks like this. Oh, I've thought about doing that. It kind of reflects a specialization of labor early on, that things get cheaper because you can specialize a bit. You know, you can have one person making the product and the person doing the accounting. But generally speaking, just to sort of harmonize it with the marginal cost we've talked about before, we're just going to make it always increasing, right? It kind of looks like, typically you might see it look like this, and it's increasing most of the time. We're just going to have it always increasing, just like we see here with the 4, 6, or the 4, 8, 12, 16, 20. We are also going to have average total cost. Average total cost, you see, forms a U shape where it starts out really high because the average costs are really big, and then it dips down, and then it goes up again. It will always intersect marginal cost at its lowest point by mathematical definition. So the intuition is that one way to think about it, average total cost, rather than thinking average total cost, think of GPA. GPA, grade point average. If you get and the marginal cost is kind of like your marginal GPA, or you take one additional class. If the grade you get in that class is less than your GPA, then your GPA is going down. If the grade you get in that class is higher than your GPA, the GPA goes up. So in other words, it's downward sloping when the margin is lower, it's upward sloping when the margin is higher, which means it has to be equal at the lowest point, at that point of transition. So when the marginal costs are really low, then average costs are falling. When marginal costs are really high, then average total costs are rising. It's a little hard to see in our numbers because our numbers are kind of lumpy, but that's the rule. So now what we do is we solve the diagram, and this always is going to follow exactly the same rules. The optimal is always where marginal cost equals marginal benefit. In this case, marginal benefit is marginal revenue. Our profit maximizing quantity is always where marginal cost equals marginal revenue, right here. Let's maybe draw a straight line straight up. This quantity becomes our reference point. Then we ask, at that quantity, what is the price we charge? Well, that's going to be fixed. At that quantity, what is our cost per unit? That's where we reference our average total cost. That's this distance is our profit per unit. This is the number of units, and that's our profit. And that's really all there is to it in this diagram as far as figuring out if the company is making money or not. Note if average total cost was all the way up here, then we've referenced a really high cost per unit compared to how much we're getting our revenue. and thus would have a loss, a negative profit, rather than a positive. Now, one thing we didn't talk about is an average variable cost curve. So recall total costs equals fixed costs plus variable costs, or total variable costs plus total fixed costs, which means average fixed costs plus average variable costs equals average total costs. Just divide everything by Q. In other words, we can draw a second diagram, a second line. Now, the shape of the average variable cost is going to look something like this. It's a very, very big difference here. When Q is small, it's going to be a very, very small difference when Q is big. And the reason why is because average fixed costs, the part that we did not include, is going to be very, very huge when we produce very few units. It's a fixed value divided by Q. And then that number is going to be very, very small when we have huge quantity, because it's going to be a fixed value divided by a much larger number. But basically, what's useful about this is that it gives us these zones of shutdown. So let's imagine, like here the company is making profit, but let's imagine the price was here. The price is below average total cost, but above average variable cost. The firm is covering its variable costs, like it's paying its workers, it's paying for ingredients, but it's not necessarily covering its fixed costs, like the rent on a store or its loan payments. This is kind of a special little place. In other words, the firm can survive in the short run, but it cannot survive in the long run. Right? It can, maybe go into a little debt, it can be a little late on its payments, but it can still pay its workers and ingredients and even turn a profit. And note, because it's fixed cost, or cost it has to swallow, regardless of if it produces a lot or if it produces a little bit or if it produces zero, it's worth it to stay open even if it's losing money. It's the difference between losing a little money and losing a lot of money. Okay? This is kind of, so it's actually making a little bit of money here in the short run, even if it's losing money in the long run. So the low point of the average total cost curve right here, so a long run shutdown point. It's the lowest price that it can be, and the firm stays open over the long run. You might lose money day to day, even quarter to quarter, like some retail stores might do, but it's not so much that it can't cover its variable costs and stay open. So this explains why some stores are open even when there's not many people there. It's because it doesn't seem like this could do this forever, and it can't do it forever, but it can do it. They are making enough business to pay the workers who are there to keep the lights on. They are essentially able to cover the costs that they would otherwise avoid if they closed. But sometimes it can't even do that. If the price falls all the way down here, if it goes all the way down here, then it can't even cover its variable costs. It can't pay its workers, and that's when it closes. It cannot stay open over the short run. So this explains why ice cream stores sometimes stay open even during the winter. It's because they get enough business to pay their workers and to pay their ingredients, even if they don't get enough business to do that forever. And other stores don't even get that enough business. Some ice cream stores close during the winter because they operate on really tight margins, and they really are on the cheaper side, and therefore they can't even cover their workers. They don't have enough business to cover their workers' salaries, or maybe to pay ingredients. They just don't have the demand. So this kind of predicts that nicer, maybe fancier ice cream stores will stay open all year round. They have a higher price so they can cover their workers, while less sort of bare bones kind of ice cream stores, cheaper kind of ice cream stores, tend to close during the winter. You can't even cover it. So that's our perfect competition diagram. Remember, the rules are going to be identical every single time that you do any sort of diagram like this. First, you find the quantity where marginal cost equals marginal revenue. Then you ask yourself, at that quantity, how much does each unit sell for? Here again, because we're in perfect competition, price is constant. Marginal revenue equals price, so that's pretty straightforward. Then you ask, at that quantity, how much does each unit cost to make on average? In other words, at that quantity, you reference average total cost. And the difference between price and cost per unit is the profit per unit. And you multiply that by the quantity, and you get the total profit, or if it's negative, the total loss. And that is going to be a sequence of things we will consider and remember when we move forward into Monopoly. But first, we're going to add a little bit of dynamism to this diagram in our next video.